stuff to remember. Oh, that's cool.
Yeah, I don't know if screencast was there or not. It's maybe one of those things they only do if you get paid for it, which unfortunately you do.
I do.
Oh my god.
You can only be a Christmas miracle after Christmas.
Oh, I like it.
Fair enough.
I hope it's a chick. Good morning.
Wow.
What's so good about Wednesday?
No.
Is 2 Chainz still a rapper? Do you guys know who 2 Chainz? That's what I was thinking. 2 Chainz, I put double chain. But I don't know if that was like. I don't know if he's old now or not. 2 Chainz. The Z, right?
What's a rapper? Is that someone who does the rhymes?
I got you, fam. Alright. I'll just start with these. So write those down. And we are just going to circle the outside function, or circle the big guy. In a second. I'm just waiting for you, right?
Yeah, he knows that. Yeah. He said I'd share it with him and probably call.
And text. And tweet him. And Insta.
You said these are recorded gifts. That's so weird.
Okay. So, we get into now you know how to take the derivative of trig functions. I mean, maybe you know. You're close, right? How many are those memorized?
I have sine and cosine memorized.
I have.
Remember yesterday when I was like, tomorrow's going to be really hard unless you know the. So you should. Bunch of jerks. Now, don't give me the I tried.
did.
Well, okay. You didn't try that hard then. Yeah, okay, yeah. But here's this. I'm not saying this. Not saying this is what you're saying, but this is not an understanding issue, right? This is because people will be like, "Oh, I didn't get it." What do you mean you didn't get it? You have to. It's effort. It's 100%. I'm not saying I'm not making fun of you, but
My memory is fragmented down, so that's going to take me forever to memorize.
But here's the thing: if I told you I'll give you $10 million if you know those by tomorrow, I mean you could do it. So it's just a question of effort. It's not a question of like I didn't get it.
Actually, I was even for 10 mil. I don't think I'd be able to.
Yes, you could.
I'd be up all night trying to, then I'd be half asleep when you quiz me on it, and I'd fall asleep halfway through, so I wouldn't get the 10 mil.
All right. Okay. Anyway, so there's kind of different ways that they can write these now, and depending on where. So basically, almost all these combine a power and a trig function. Depending on where they write it, changes what the big guy is. So first of all, I want you to realize that these two are the same. So I can write the squared on the inside here, and like the sign is being squared, and therefore whatever is being signed is also like part of that. They will present questions in this way usually. The first thing I will recommend you do on all of those is rewrite it like this. Because to me, you don't have to, but to me it's a lot easier to look at this and say, what's the outside function? Is the square. Where when I look at this one, I say, what's the outside function? I think it's harder. You almost could say the sine. You could say, like, there's different options. So it is the squared in this one also. But my first piece of advice on these, when they give it to you like this, is to rewrite it like this. So the power's on the very outside. And then what's the outside function? Well, it's the one on the outside. And this is different. So what is being squared here is not the sine. So here, your biggest outside function would be the sine. And now we have 3 levels. So there used to be big and little. Now it's big, middle, and little. So like in this one here, and this is why I have you write it, it's just easy to tell. What's the big guy? 2. I always feel like sexist. Is it okay that I say guy every time? Should I say like big girl, little guy? Anyway. that seems way worse. Yeah. All right. Big person.
Big talk.
What's the big person here? The 2. What's the middle person? The sine, and then the little person. That's not bad too. It's 3x minus 4. In this one, what's your big guy? The sine. What's your middle? The squared, and the little would be the 3x minus 4. So the first part of all these is identify. You're gonna have 3 levels now, so you gotta identify what's the big, what's the outside, what's the middle, what's the inside, what's the big, what's the middle, what's the little. So let's do a couple. So let's say y equals sine to the 4th of 3x squared. First of all, I would rewrite that immediately. I think it's much harder with that 4 in there. And, I'm not going to come around and check if you're rewriting them, but I think you're much less likely to make mistakes. So, the double chain rule is just the chain rule with one more level. So we used to take the derivative of the big guy, leave the little guy alone, and then take the derivative of the little guy. Well, now we're going to take the derivative of the big, we're going to leave the middle and the little alone. Then we move on, we take the derivative of the middle, we leave the little alone again, and then we take the derivative of the little. It's all multiplied together. So, the big guy here is the 4, right? So the way I take a power is I bring the power down, reduce by 1. What do I do with everything else? Leave it alone. So I've taken the derivative of the big, and I've left all the things smaller than it alone. So I've done the big. Now I move on. I'm going to take the derivative of the middle, and I'm going to leave all the things smaller than that alone. So what's the derivative of, so what's the middle guy? The sine. What's the derivative of sine? Cosine. And I'm going to leave the little guy alone again. So the little guy gets left alone twice. And then I multiply by what? So 6x in this case, the derivative of the little guy. And the nice thing about these is you're done. Like it's a harder step, but there's not like, combined like terms, get a common denominator, do all this other crap. It's just, well, so if it's a negative x1, you can flip it to the pot, and that's not that big of a deal. Questions on that process? I mean, we're going to do several more, but I think I can answer at this point. What are you doing over there?
I'm nothing.
Just open it.
I did.
Oh, okay.
It's just loud.
It's okay. Well, it sounded like you were trying to open it quietly, and then it was taking like 5 minutes.
No.
Right, it's like.
Sorry.
Alright, let's say that one. I think that looks a lot scarier. It's not. Well, one of the reasons it looks scarier is because you didn't freaking memorize the derivative of cosecant. That's my fault. So that's your fault, I think. Sorry, that's not my fault at all. That's your fault. Yeah.
It's not my fault.
Second reason is the square root, but what are we going to do with the square root? We're just going to make it a power. So, rewrite this as cosecant of 4x 1/2. Right, Nate? Good? It's not negative. I'm a moron. It will be in a second, but not yet. Sorry. Thank you. So is the rewriting okay? So what's your big person? 1/2. What's your middle? Cosecant, and your little is the 4x, right? So we do the big one first, and we leave the other two alone. So the big one is a power, so it's just 1/2 and then negative 1/2. And then I move on to the middle. What's the derivative of cosecant? We just read it off your list. Negative cosecant, cotangent. So, negative cosecant, cotangent. Remember the little guy goes in both spots? So the 4x goes in both of those spots. And then, so I've done big, I've done middle, now I get to the derivative of the little. So I took 3 derivatives. This is me taking the derivative of the big guy. This is me taking the derivative of the middle. And that's the derivative of the little. And in this one, I'm not done. There is one more step. But the main work is done. Are there questions on that one anywhere? So I can't have negative exponents, right? So I'm going to put the 4 on top. So I'm just going to do 1/2 times 4. What's 1/2 times 4? 2. So I'm just going to put 2 on top. Putting that negative out here. Cosecant of 4x, cotan of 4x goes on top. And then cosecant of 4x to the 1/2 goes on the bottom. Sorry, I know this is probably hard for people to see. Is that alright? Can you guys see what's going on? Like in the back, can you see when I write down that low? We okay? You guys, sorry. I can rewrite it up higher. You alright?
I can see it.
Ruff, you good? Caitlin, you good? Can you see anyways? Alright, let's say that again. I think it looks a lot scarier than it actually is. So if I rewrite it, this would be 4 times secant of x squared to what power? Negative 1/2, because I got to bring it up, right? That 4 is not a big or little person or guy or girl, whatever. The 4 is just a constant. It's just kind of there. It's just hanging out. So that's not a function of x. That's not like doing it. That's just a constant. So what is our big guy here? Negative 1/2. The middle, sec, and the little is x squared, right? So try it. And try to get rid of the negative exponent at the ends. What'd you open up over there? No, I like them, but it's like not worth it. No thank you. If I did, I would have asked. I'd be like, you interrupted my class, so give me some. But it's okay. Thanks. No, it's not that big a deal. I'm just listening. I'm not trying to stress you out. Sorry. natural logs, and like a constant 2 powers, like 8 to the x or something. Then we'll do that with double chain rule. Then we'll do all of that stuff with quotient rule, product rule, chain rule. And then there's one more type of derivative that you'll need to learn, which I can't even describe yet. It won't even make sense to you. But what's coming up is what I call it. It's what's called a gateway. I don't know if you guys have heard about this from like past years. So when I went to Michigan, I can't do it like they did there. But when I went to college, they had you took the regular calc class, but you also had to pass this gateway. So you had to go to this separate testing building at whatever you wanted, sometimes through the semester, and pass this test. You could take it as many times as you wanted, but if you never passed this test, you failed the class. So it was just like a bit like you should be able to do these things, and if you can't do these things, you can't pass the class. It was like a separate condition. So I can't do that in here. I'm not going to say if you can't pass this test, you can't pass the class. But I want to do it similar because it really made me study more than just a regular test. So when we finish all the derivatives, I'm going to give you a 10-question test on derivatives. Take the derivative of these 10 things. There's going to be no concepts, no tangent lines, no horizontal tangent lines, no normal lines, none of that stuff. Straight up, can you take the derivative of these 10 things? You cannot get partial credit on it. Is the hard part. So like on that last question, if you forgot a negative sign, I'm going to mark it wrong. But you get to take it 3 times. So like in college, I could take it infinite if I wanted, but we don't have time for that. So I'm trying to like semi-recreate that in a high school environment, you know. So just be really careful about this because I know about the problems. I know it's really easy to just kind of like look at your problem and be like, oh, I got it right, I just missed a negative sign. Oh, I knew it, I just missed a 2. Well, like that matters though. And so when you're doing this gateway, there is no partial credit. So there's just so many chances to screw up.
That was me.
That you're like, you have to really focus to make sure you're getting all these little things. That's kind of the point of the gateway is to make sure you're getting the problems like 100% correct. And as a competition for that, I guess, I'm giving you 3 attempts, I'll take your best score. So there's like the trade-off. So just so you know what's coming, so you can keep that in mind while we're doing this stuff. Do you have a question?
I was going to ask you.
Yeah, so some people will get, I mean, every year, I'd say like 3 or 4 people get 100% the first time, and then they just sit there for 2 days. Like, do whatever they. Yeah.
You mentioned 8 to the x earlier. Wouldn't that just be like x times 8 to the negative x?
No, because the variable is in the power now instead of downstairs. It changed it.
So you can't just use it.
You cannot. Yeah. Alright, anyway. Let's get back to this. So, the biggest outside function is the negative 1/2. The way I take the derivative of that is to bring it down and multiply by what's in front, reduce the power by 1, and then I leave the stuff inside alone, right? So I've done the big, so like check mark on the big. So here, I took the derivative of that. Everything else I left alone. Then I move on. So the next one is sec. What's the derivative of sec? Sec tan. You leave the little guy alone. So you leave the little guy alone twice. So now I've done the sec, and I haven't yet taken the derivative of the x squared. So at the very end, I multiply by 2x.
Here's another question.
Yeah.
Why do you say it as secant times tangent up there, but you have it written on the whiteboard as tangent times secant? I know it doesn't.
I don't know. It doesn't matter. I don't really think. I think I usually think sec tan. I don't know why I wrote tan sec tan. Is that confusing? It doesn't matter though, right?
It truly doesn't matter, but my brain
It's messing up your memory.
Yeah,
I'm gonna rewrite it as
I
sec
process
tan.
it as tangent times secant. It's like, I don't know. Yeah, I know it doesn't matter, but
Does this
I
help?
just was curious.
There you
I
go.
don't know.
Okay. So rewrite this. Negative exponents go on the bottom. So sec of x squared to the 3/2. And on top, I have negative 4x times sec x squared tan x squared. So there is, and you are not required to do this. So on the gateway, you don't have to do this. On a free response on the AP test, you don't have to do this. On a multiple choice on the AP test, they would cancel out just have to be able to recognize, you don't have to take this step, but you have to be able to recognize that this is the same thing. They would probably do this, actually. So do you guys see what I did there? So there's a sec x squared here, there's one of them, and there's 3 halves of them down there. So if I do this, if I subtract out what'll cancel, I'll have 1/2 of them left down here, and then they would probably write it as a square root. Again, you are not required to take this step on a multiple choice. You got to be able to know, this is the same. Questions on that? All right, so all the ones we've done so far, the big guy's been a power. Let's look at it if it's not. Let's say that. So first I'll rewrite this so there's no radical, right? So cosine of 3x minus 1 to the 1/2. But in this situation, is the cosine being raised to the 1/2 power? It's not. It's just the 3x minus 1 that's being raised to the 1/2 power. So what's your big person? The cosine. Your middle is the 1/2, and your little is the 3x minus 1. So it's kind of like that. If you want to throw an extra pair of parentheses there to help you see a little easier. So we do the same process though. We do take the derivative of the big guy first. What's the derivative of cos? Negative sign. We leave the inside stuff alone. And then I work my way down the list. So what's the middle guy? The 1/2. So that's what I take the derivative of next. So bring it down, reduce the power by 1. And then, so, I've done the big, I've done the middle, so then I need to multiply by the derivative of the inside, which is 3. And I'm going to rewrite it, but before I rewrite it, other questions on what I did to get to that. So no negative exponents, right? So the 1/2, I'm going to put a 2 in the bottom. I'm not going to put the 1 because I know there's going to be other stuff up there anyways. So the 3 I can throw up there. This negative I'm putting here. Sine of 3x minus 1 to the 1/2 goes on top. And then your 3x minus 1 to the 1/2 goes on the bottom. Can I cancel out those 3x minus 1 to the 1/2? I cannot. 1 is being signed, 1 is not. So if I had sine of 30 over 30, let's say I did cancel them. What would be left? Just sine of something? I don't even know. So no, you can't cancel this. That's supposed to be nice. Questions on 4 at all? You guys seem like you're doing it right. This isn't that bad, right? It's not awful. Yeah, we gotta practice. Try that. Tan's your big, -2 is your middle, 4x squared minus 1 is your little. And the reason for that, like the difference between this and the other ones, is the power doesn't apply in this case to the trig. So you might want to do that again. Like that might make it easier to see. So the big guy, what's the derivative of tan? Secant squared. Leave everything else alone. Then we go down to the middle. So the middle is a power. The way you take the derivative of powers is bring it down, reduce by 1. You leave the inside part alone. And then we multiply by the derivative of the very little guy. So with this one, you can't really rewrite this without negative exponents. Because if you try to like flip that to the bottom, I mean, I guess technically we could go secant squared of 1 over 4x squared minus 1 squared. I don't really think you need to worry about that. Times -16x over that to the third. I don't care about this part. But you should have put the 4x squared minus 1 to the third on the bottom. I think it's probably just as good to do this here. The rest of it should match. So that now we should be good. How many had that? Questions? Okay. Well, you were like, I didn't know if you were raising your hands. What was that? Grabbing out for help? What was going on? So I guess I'm at the point, like, do you want to do more up here together, or you just want the worksheet and start doing them on your own? On your own? I mean, I'm still here. Like, you can still have questions. It's like,
I literally saw her carrying this bag.
you got 3 left there for you. So remember, starting tomorrow, it's fair game for me to give a quiz on those derivatives. If I chose to tomorrow, second you walked in, I could be like, here's, put everything away, give you a quiz on those 6. And then we're learning 4 more tomorrow, which you will also be responsible for memorizing for, you know, after that. Then we'll be 10. Then we're learning 6 more. Then it will be 16. It's weird. Like, to learn stuff, you have to learn stuff. It's crazy. It's obvious problem.
Where is she?
Then you took the derivative of the negative cos. If it was negative cos, you took